So it's a two-dimensional sheet of rubber, and the height of this over the plane xy represents the value of the function at some point xy. So if you want to know the function value at some point xy, go out to that position on the plane, measure how far above or below the plane this sheet of rubber is. That's the function value that's stored. Pretty easy to visualize an implementation of a particular function like this, assuming that we have some way to measure the height of this material at different points x, y, and again, a daemon inside the cell could move over and take a sounding and figure out what the function value was and set the output accordingly. To do this more practically, don't know, but it's a starting point for some sort of model for how to code a function of two variables. Now, C mode gets a new set of challenges because, again, we can't just move from one value of x to the other. We need to do some kind of raster scan because we have a two-dimensional space of x, y values that we need to cover in order to read out this function and send it through a D output, or take a D input and use it to create a new function. So picture some kind of raster scan where you start moving across very quickly in x and more slowly in y, and you just pick up the function value at each of these points, and that becomes the D output. And if you're in receiving D inputs, you do the same kind of scan and you adjust the height of this membrane at each point based on the incoming voltage level. And so you can take this function, this shape, send it out, read it back in, copy it, and so on and so forth. There's an unfortunate discretization implied here, though, in doing this raster scan, and I don't know an easy way to get around that. It may be that we can use some kind of space-filling curve to raster scan through this infinite length sweep pattern in a finite amount of time. Clearly, if we just go across and we move up by an infinitesimal amount, we're not going to cover the region in less than an infinite period of time. But maybe a space-filling curve that lets us hit every single point in some finite amount of time. Physically, though, it's really easy to make a replica of this surface, right? Just take another piece of rubber, heat it up, drop it on top so it deforms into the same shape, let it cool, take it off, you've got your new function. So I don't know if we can mimic that kind of process in some sort of automated way, and I also don't know how we would read that out. But ideally, we're not reading in and out sequentially. We're actually taking the essence of the function and just shooting that out a D output in C mode and taking a similar essence in and using that to create a new function for the cell when the cell's in C mode. So we need to be careful to not get too caught up in the serialization that goes along with the cell matrix and really try to think about just sort of more bulk operations. What are we trying to do? Take this current function, send it out, take an incoming function, plop that into the cell. All right, what about 3 dimensions? How do we code a function of 3 variables? Well, this is getting a lot harder now. So let's draw a 3 space. So here's x, here's y, here's z. And now let's think about filling this with a gas. And at each point x, y, z, suppose we can set the temperature of that gas. Not possible, but suppose we could do that so that this point has some temperature and this point has some temperature and this has some temperature. And now if you want to know the function value for some inputs x, y, z, simply go to that point in space, take a temperature reading, that's the function value, scale it, etc., all of that stuff. If we impose certain continuity conditions, this starts to be something you can almost imagine might work. Certainly we can't instantaneously change from some temperature to another temperature, so we need some kind of continuity. But you can kind of imagine if we had a way to control the temperature at all points in this space, that you might be able to do something like this. But not with any technology that I know of. A similar idea might be, instead of having a medium like a gas, to use light and something holographic to record a phase at each point x, y, z in this space, and then we could read the phase at each point, and that phase would map to the stored voltage value. And at that point, copying this function into another function is a matter of making a photograph, almost a holographic photograph of the information stored in this three-dimensional phase recording. If you can take that and replicate it somewhere else, you've got your C-mode operation. So those are just some ideas. Four-dimensional function of four inputs gets much stranger really quickly. That's another reason we've been working with three-sided cells instead of four. But you could start playing time as a fourth dimension and have something where you have temperature in here changing over time. And if you want to know the value at some x, y, z, t, go to that point in space, wait until that point in time, and then take your temperature reading. But that starts to get into all kinds of directions that aren't really desirable. So three-sided cells are what we're pursuing architecturally, and there may be some possibilities for physically creating these structures. All right, that's all I have to say on sort of the background and the architecture of the Songline processor. The next set of videos is going to look at the simulation, and all the work's been done in simulation, some of it software, some with some hardware in the loop. We'll look at the software tools for that, we'll look at the hardware, we'll see some sample circuits, how to compile things. I'll talk you through the tool sets and the operations of the tools, the compiler, the configuration setup, and so on. And we'll see how we can actually explore some of these. Future videos we'll talk about possible applications, we'll talk about some of the machine learning work, and there'll be some links to publications elsewhere on the page. All right, that's all for now. Thanks.